So, hello everyone. I hope all of you are doing good and all of you are preparing in the right path. So, in the last video also, I have told you like how to study about the complete things, like how to prepare for the second attempt and how to study the organic. And even though I got some inquiries about how to study, to prepare for the like advance, definitely I will do a video in coming sessions for preparing for advance. I just have a only one suggestion for that. Again, the PYQ method will help for advance also. The same things, but the questions will be somewhat tricky kind of and lengthy kind of. So it's better to practice PYQ questions and like again the same thing. The analysis of that particular question from where did it came from and restudying if you don't know that particular topic, it will help you. So soon we will do a particular analysis plus taking some questions and how to study for that. Before that, I am going with the reagents, how to study with the organic. So why did I take with an example of this? Hydrocarbon reagents is very important because it will be always mixed with some other things. Direct question from other chapters can also come, whereas it is mixed with a particular reagents of other chapter. Once you study all the chapters of organic, now it's no more separate, it is a single thing. Okay, so it will come all together in one question, especially in advanced kind of things. Now it is very better to know and it is very important to know how to approach the organic. If you are not approaching it in a proper way, then it is very difficult to study it. Okay, so here I am just listing all the organic reagents of hydrocarbon chapter, and I prepared the notes in such a way that so you guys can also prepare in the same way for all other chapters. Okay, so for example, you see here reagents of hydrocarbons starting from the alkane, alkene and alkyne, from the preparation to the reactions. Everywhere, if you can recollect all the preparation and all the reaction, it is good. But what I will suggest, like you have to list out all the reagents in that chapter. You can see here all the reagents I have listed out here which comes in that particular chapter. Now this is actually a note which says about the particular function or particular important things about that reagent. For example, H2, we know it is hydrogenation in platinum or palladium, nickel. I didn't add that, nickel, palladium, like Saberger's reaction which is given in NCRT. So that is also important, but I actually forgot to add it. So this particular things, everything is doing in the same same thing. So when you are thinking about this, when you have seen this reagent, you should be able to recollect or think about all the particular concepts or important things related to that things which is in the NCRT plus which is important in that particular reagent. For example, this is a syn addition alkene to alkene or alkane to completely directly to alkane, and the reactivity about this less cloudy is easy to hydrogenate. For example, if a double bond is like this and a double bond is like this, sorry they are not like this, and here hydrogen hydrogen hydrogen, something like this is methyl group, this is more cloudy, this is less cloudy. So if you are getting with one more of H2, this will easily be get hydrogenated. So that is about the reactivity. So whenever you are taking a reagent, you should know about the stereochemistry aspects and you should know about the important other things like reactivity, because that only will be repeated, right? Now if I am saying Zn in metals, it is used for the hydrogenations again, for the reduction. Like you can think like metal in acid will produce hydrogen gas, so alkyl halide can be converted to alkyne. Okay, alkane reduction, RCl or RX to alkane directly. So if mechanism is not given here, the mechanism is not provided anywhere, so no need to worry about it. So but this reagent, if it is given, you should not doubt what it is doing to do. You should know this one. So I don't want you to write the whole things somewhere. You can actually download this one. I will try to provide this PDF if it is possible. Otherwise, I will try to provide the link of this to download this PDF. Now, as I said, I don't want you to write this all functions there, okay, because you already have this PDF. I just want you to write this particular like reagents alone in your note or some PDF or like in paper or some word, and these all points it's there. This you have to recollect when you are seeing this particular reagents. That's what you have to do. Okay, for example, Na in dry ether, these all are very common. It will be, it is Wood's reaction, the name of that reaction, and what it is actually doing, alkyl halide to the symmetrical alkane. And what is the mechanism? Mechanism is provided, therefore it is free radical. Even though it is free radical we know tertiary greater than secondary greater than primary stability. Even though it's free radicals, its rate explained on SN2 attack, because we are studying two mechanisms for this. One is ionic and one is free radical. So this particular R minus is going and attacking on another Rx. This is actually the mechanism explained or the rate explained by that. That is the way it is. That's because it's primary greater than secondary greater than tertiary. So that is another more important thing. And now to prepare symmetrical, unsymmetrical, it is only for to prepare symmetrical, unsymmetrical, no good yield. And what was the reason? That also should come to your mind, because it is an NCERT point. Right, when you are preparing unsymmetrical or when you are taking two different alkyl halides, you will get a mixture of like alkanes. So since alkanes has very close boiling point, it is difficult to separate them. So those things and the reactivity. So whatever all things is related about that particular reagents, you have to recollect those things. Example, zinc in dry ether Franklin, mechanism is not provided much, so no need to worry. And the same way, whatever you are getting is same kind of things. It just Z and X2 is removed. That's it. Now, copper in dry ether and Ullmann reaction only for aryl iodides. These all are the some directly. When I am getting this particular things with this, you should know what is that reaction. That's it. And some other important things I have to say is, all thing I have I'm not explaining these all things. If you need the explanation of all these things, please let me know, that I will do with a detailed explanation. Because if I explain it, it will be like I'm taking the hydrocarbon complete chapter. I don't want to do that, because I need you guys to practice more at this time by looking at all the this particular reagents and go through the points once. If you don't know, if you already know, you just recollect it and do more questions, because this time is to do more questions rather than only focusing on theories. So this kind of short notes will help you, because I don't want you guys to prepare separately, so that you guys will waste time on that. So that's why I try to prepare one and show you how actually to go with, so that it will be easy for you guys. So everything, for example, decarboxylation. In decarboxylation, again intermediate is carbanion. So since carbanion is intermediate, reactivity will depend on the stability of carbanion, because they can ask what is the rate of order of rate of this particular decarboxylation, which will be more. And beta keto acid only require heat, it does not even require NaOH and CaO, soda lime in 3:1 ratio. So these all are the important points about this particular reagents. Now if you are going with Clemmensen, we know Clemmensen reduction is a double bond will be converted to hydrogen, but there is an important topic, important point you have to remember. For example, it is acid sensitive, because it has an acid, concentrated HCl we are taking. So if any group is there which can react with this concentrated HCl, it will react. For example, OH. If it you react with concentrated HCl, H plus will attack and H2O become a good leaving group, and this will leave, and Cl minus as a nucleophile will come and attack. So it's not only that C double bond will get reduced here to hydrogen, but also this OH will be replaced by Cl. Not only this, any kind of acid sensitive group is present, then that can happen there. Any kind of acid reaction, acid base reaction or anything else can be done, that can happen there. So you should know that Clemmensen. So better method, if you retain this OH here and you have to prepare this, then the better method will be this one, Wolff-Kirchner, N2H4 and OH minus. So if you know this reagent, you should be able to recollect all the important things, and if you know this one, should able to recollect all this. Here it is base sensitive because here OH minus and heat, so if there is an elimination possibility, that can happen. So this is actually base sensitive. Now Grignard reagent. Grignard reagent is very important because it is very repeated questions. R minus Grignard reagent, we know this is an ionic, it's not an ionic bond, it's a polar bond, R minus and MgX, polar covalent bond. Okay, so here since we know carbon is attached with a metal, therefore metal will give partial positive, here it will get partial negative. Now this is very important because this is used to increase the chain. You have to attach an R because normally carbon will not get negative. Carbon usually attached with halides or more electronegative atoms like oxygen. So carbon usually get positive. So whenever you need any particular carbon to act as a nucleophile or base, you need to take an Grignard reagent, right? So this particular negative charge here can act as a base also to abstract H plus, and it can act as a nucleophile also to attack at a partial positive site, right? It can also attach at an electrophilic site. So these two functions also RMGX will do, I mean Grignard reagent will do, but where it will act first? Priority is as a base. So don't confuse, if one mole is only there, then first it acts as a base. If any acidic H plus is present, then it will act as a base actually to abstract the H plus. So whatever acidic hydrogen is present in any molecule, it will abstract the H plus. If not, if any electrophilic site is there, this electron will go and attack there. So don't get confused, first priority is for as a base, because in all the things acid base reactions are the fastest reaction. It happen actually in 10 to the minus 8 seconds. Something is, I think it is given in your kinetics chapter. I don't remember now the point exactly, but I feel like that, whether it is precipitation or acid base, I don't remember. But this is acid base reaction, which is very very fast reaction. So that will happen before nucleophilic electrophilic reactions. Okay, so this act as a better base, also nucleophile. If not base, then act as a nucleophile. Okay, so that kind of things. And red phosphorus in HI. Red phosphorus in HI is the strongest reducing agent you have. The strongest reducing agent means all the oxygen containing compound, even the RCl, I haven't written here, RCl also, even RCl means RX also will be converted to alkane. All the oxidative thing means RH is the most reduced one. Next, alkyl halide is also oxidized. Why? Because halogen is an electronegative atom, then carbon will get partial positive. So oxidation increase slightly. So it is an oxidized. Okay. So ROH, here also oxygen, therefore partial positive will come. Here also oxygen added, therefore oxidative. Then alcohol. Then will come aldehyde or ketone like this. Then it will be go to RZ double bond. If more oxidized, it is carboxylic acid. If further oxidized, it is CO2. Like that, it is the oxidative nature of this one, right? So whatever oxidized one will get completely reduced to respective alkanes. The same alkanes with the same number of carbon atoms. Here RH, here RC is there, therefore RCH3, here RCR is there, therefore RCH2R. Like that will go. Now there can be questions come in advanced point of view or some other point in mains also. The number of HI used, XHI. There is a trick for that, a common trick. If RCl, no, like RX, you can just use one HI, that is enough to replace with hydrogen. But if you have oxygen, carbon oxygen bond, you take one bond, then into two HI you have to use. That is number of HI is equal to number of carbon CO bond into 2. Here you see 2 bonds are there, so into 2 4 HI you require. Here also 2 4 HI. Here how many? 3, therefore 6 HI you require. So that is actually a trick you can use that. Now the same thing, Kolb's electrolysis, Kolb's electrolysis, it is an electrolysis, oxidation is happening. Again, I am not going for the mechanism completely. If you need it, just comment on this. If you need any particular mechanism to be know, or to discuss, or you feel like difficult, anything, you just comment on it. I will do that, or do detail on that. Okay, now you see, because why I need, because you already are at the end of this, you will be having your better notes with you, class notes with you, any guides with you, which will give the detailed mechanism. But the main thing you should know is how to approach it. That's why I'm doing this video. Okay, now this you can see, in Kolb's electrolysis, what all points should come into your mind? It is, again, the mechanism is free radical. So free radical is forming, right? Free radical is forming. So first oxidation will happen, one electron lost, and this one electron will initiate the other electron to lose from here. So this will make cleave from here. This will make a carbon dioxide. R radical will form. So R radical and R radical will combine to form RR. Now what is important? What is it anode? Anode is alkane and CO2. What is it cathode? Hydrogen and NaOH. This all should come into your mind. Okay, you shouldn't write this. All should come into your mind while the moment you see this. Now if nearby two radical form, they form stable double bond. Yeah, if RR radical is like this, then it is forming the double bond. So you should know how to approach the question. Now this is NH2, NH2, H2O2. It's not a common and repeated one. Still it is in this chapter. It is transfer hydrogenation. This particular thing will be hydrogenated. It is the same like hydrogenation, but it is a kind of syn addition, where this NH2 is changing to imide like this. Okay, will oxidate by this one, and this hydrogen will get added from this in the syn addition, and N2 will get eliminated. So that is a there is again the intermediate what is forming 6-membered cyclic transition state is forming. So main thing is about the intermediate forming, transition state forming, or syn adhesion or anti adhesion. Those all things are very important. Okay, now come to here. See, this is an important exception which I have taken from NCERT. I think till the date it hasn't been asked, but there is a chance because it is directly given in NCERT. We know that when you are taking the melting point, generally we will say that even number like 1, 2, 3, 4 have a better stacking arrangement. Because of that, it has a good melting point. Generally we will say that, but it's not always valid, right? Because as the number of carbon increases, for example, methane, ethane, propane, butane, like this, our number of carbon increases, definitely melting point. I'm saying about melting point, no boiling point. Okay, again, very important, melting point. So you study, you shouldn't study, you have to study perfectly. Melting point I'm discussing. So as number of carbon increases, generally there is a trend that it's melting point also increases. That is correct. After number of carbon, then only this all things odd and even. First thing is about the more the number of carbon, more will be the melting point. But there is an exception which is given in your NCERT data also, that ethane melting point is more than that of propane. You can expect this. I don't know whether it comes or not, but this is an exception which can become or it cannot become also, because this time from chemical bonding they took a direct table data. If you remember that COC and bond and all, so bond strength and all. Okay, so like that you can expect this. This is an exception coming from that particular chapter. Now reactions of alkane, what is this reagent doing? This is, we know, free radical halogenation. So if it is free radical halogenation, free radical is forming as the product. So intermediate is free radical, therefore reactivity will be tertiary greater than secondary greater than primary. And fluorination is highly explosive, highly reactive and explosive, and I2 is slow and it is reversible. Therefore you have to carry out, it is in the presence of oxidizing agent. Oxidizing agent HiO3, HNO3, like that. But fluorination can be taken even in the dark also, because it is very highly reactive. Usually we will not do that. Okay, if we have to do, you have to use N2 as a cooler. Br2, We know the reactivity order is F2 greater than Cl2 greater than Br2 greater than I2. So you can see this is reactive because more reactivity, whereas bromine is less reactive than chlorine, therefore it is selective. Very important this one about this. Selective means it can select which is tertiary, secondary and primary. Predominantly it will go and attack to the tertiary position. Tertiary hydrogen it will replace. But chlorine is not like that. Chlorine will replace according to the reactivity. There is a formula for that also to exactly know the percentage yield. If you don't know that, just comment on it. I will do that. Otherwise, you have to know it. I hope it will be in your notes or it will be in your hands. Now this just I have given this particular reactivity order of 5 primary, secondary, tertiary. You can see bromine. To choose tertiary, it has a 1600 times more chance than the primary. But to choose tertiary in case of chlorine, it has only 5 times. So here one example, one famous example, Cl2 in presence of HNu and Br2 in presence of HNu for the same thing. We know it is free radical mechanism, so it will replace this tertiary position. But with chlorine, it will actually, major product is actually primary position, because its probability of attacking 3 types, total 9 types, 3, 3, 3, right? This 3, 3, 3. 9 types of primary hydrogens are there, so the probability, since it is more reactive, increased at this primary. But bromine is more selective, it selectively replaces the tertiary hydrogens. Okay, so that is very important. Even you can find directly the percentage yield of that also. So stereochemistry questions can be expected, like how many chiral, what are the formed, how many possible stereochemical product can be formed, because this we know this is not stopped at monochlorination. If monochlorination is happened, how many possible products can be formed, and how many polychlorination or monobromination or monohalogenation or polyhalogenation can be possible. That kind of questions can be expected. Combustion and all you must be knowing. And this controlled oxidation, many times as it is came, just you have to identify the reagent and its function. That's why I said, and the mechanism is not need to worry about it, because you don't need it. It's not given anywhere, so no need it. So this kind of what MO2O3 will do, control alkene to aldehyde. Here itself you have an acetyl group, no? So alkene to acid CH3COO type. I mean whatever alkene, the same thing will convert to acid. So this particular kind of things also you should know. So I hope you understood how to study, and you can use this particular things the reagents completely. The Cr2O3 Al2O3 aromatization is very important. Again, directly from hexane to alkene, aromatic compound. And you should identify again the reagent. H2O in steam in nickel, it's actually just to convert methane to carbon monoxide. And if you are getting high heating, like cracking will happen, the lower membranes you will get, lower members you will get. Now comes to alkene. In alkene, if you have to prepare from alkyne, we know alkyne, just hydrogenation, it will convert to alkene. So if you have to stop at alkene, you have to poison it. So that poisoned one is this Lindlar's catalyst or palladium in barium sulfate to get cis-alkene. Again, there is syn addition happen and you will get cis. Whereas this is Birch reduction. Okay, I haven't written here, but it is actually Birch reduction. In Birch reduction, alkane will convert to transalkene. Okay, so this is important. For mains, its mechanism is not much important, but for advanced, you can do the Birch reduction for that aromatic when electron withdrawing group is attached, donating group is attached. Those things can be concentrated. Again, the mechanism is there important. So if preparing for advanced, it will be better that if you know something about its mechanism also. And again, you cannot use, very important, you cannot use this to reduce the bond. Okay, if you are having a terminal alkyne, because this is a base, therefore this is an acidic. This terminal alkane, due to its sp nature, this hydrogen is acidic. So that hydrogen is acidic, it will react with the metal to form the salt, and hydrogen hydrogen gas will be released. Now the next one is very important, preparation using this bases, strong bases. This negative charge usually implies that it is bimolecular reactions, E2. Okay, because for E2 we know that we require a strong base, because it is bimolecular. Base also is a part of the reaction in rate determining step, right? So I'm not again, I hope everyone know that mechanism properly. If you don't know, just comment on it. I will do a detailed analysis. Again, I'll say tertiary butoxide. See, this is a bulkier base, right? So this is not bulky, this is normal thing. So these all are strong bases. These all will abstract this particular hydrogen, and it will go for elimination. That also E2. How to identify whether it is E2 or E1, SN1, SN2. If you have any problem in that, comment on it. Okay. So like E2. Now you have two product possible, especially in this elimination, Zaitsev and Hoffman. Hoffman generally happen in presence of tertiary butoxide, bulkier base. All other case it's normally predominantly Zaitsev, means more substituted. And here transition state is formed, has more negative charge character. Again, intermediate you should know. Here no intermediate, instead transition state is formed. So you should know about that also. Like okay, so Hoffman product very important. If you have a bulky leaving group like ammonium, like quaternary ammonium salt, or poor leaving group like fluorine, or bulky base, then Hoffman will be major. Otherwise it will be Zaitsev. Now these also will give this combination. Sometimes you will get confused what it will do. These combination also will give OH minus and act as an base and elimination. There is one more important thing I want to say about why this kind of analysis is important. This note is important. For example, you should know where the rearrangement is happening, because the major product is always your problem, right? So you should know where the rearrangement is happen, where the rearrangement will not happen. For that, you should know what is the kind of intermediate forming. For example, in this, for example, which one I will take? See here, X2 in presence of CCl4, right? You know that a kind of this. Here, cyclic halonium ion is forming and partial positive charge on both sides. The nucleophile will attack according to Markovnikov side, means were more stable carbocation type. But the carbocation as it is not forming, no complete carbocation. So if no complete carbocation is forming, rearrangement there is no chance. If carbocation formed, only rearrangement is happening. So simply if you are producing a rearranged product also will be there. So you feel like okay, that is more tertiary carbon, so more stable. So if you go for that, answer will be wrong, because if no complete carbocation is forming, then rearrangement is not possible. So wherever rearrangement is happening, where is rearrangement is not possible, that you should know. For example, this one was the reagent, H plus in presence of H3O plus. Then carbocation complete formation is happening there, therefore rearrangement is possible. And here also rearrangement is not possible, because the halogen X2, a cyclic halonium ion is forming, rearrangement is not possible. So that is also important. And other than that, here also BH3, this one, you will be knowing that hydroboration oxidation. In that, one important thing is again, it is again anti-Markovnikov's rule directly, and there is no kind of rearrangement and all, nothing is possible. Carbocation, no intermediate is there. So no need to, and syn addition, this kind of things you should be knowing. Other than that, this one, again this one, this oxymercuration demercuration reaction. In that you are getting Markovnikovs. So usually when you are sealing like Markovnikovs, you will go for rearrangement. Again there is no rearrangement possible, because here also you are getting something like, right, cyclic carbocation. So rearrangement is again not possible. Even though it is Markovnikov's addition, the OH minus will go and attack from more stable carbocation side. It will not go and rearrange the carbocation to tertiary more stable, and again it will go and attack. Such things will not be there. So you should definitely know where this particular For example, you can see like no complete carbocation is forming, where the rearrangement will happen or not, that also like is very very important. Okay, so that is one more point I have to discuss in this analysis of organic chemistry. And one more tricky questions in this one is the important, when it is needed, mechanism is needed, you should know about each and everything's functions. For example, sometimes to confuse you, instead of H2O, they will give CH3OH. So directly you know this is oxymerculation, you will go and add the OH there, but it will be wrong, because if it is H2O, H2A as a nucleophile will go and attack, then you will get OH there. But if it is CH3OH, then CH3OH will go and attack it as an nucleophile, therefore it will be OCH3 node OH. Okay, so such kind of mechanism is given, there should be a proper analysis of the mechanism. That's what I want to additionally add here. So this is how to identify the whole things, study organic chemistry. You can make this kind of notes, or you can download the same things, or to use the preparations, and you can do the same kind of preparation for all other organic chapters. So I'm not discussing each and everything here, I just want you to give an idea about how to prepare the notes in organic, and I just said that this can be used for later also, for later your any exams also it will be helpful. So just go through it. I can give this link for this, or PDF if I can upload, I will do that also. Now the whole thing, the whole data about the hydrocarbon I have added here. You can just go through it. Very important points of everything. If mechanism is not given, then no need to worry about it, they will not ask. Okay, so I hope everyone must be liking this. If you need each and everything to be discussed from this particular note, just comment on it. Just do more questions with a proper note, stick on to that, and to do more questions, revise it properly. Doing more PYQs will help you at this stage. So I hope everyone like it. If you like it, comment on it, and just subscribe to this channel if you need more kind of contents. Okay.